You know what? Maybe I'll introduce you now. Uh, First, I want to welcome you here to Montreal. Have you been here before? Paul, have you been here before in Montreal?
I've been in Montreal, but not at the university before.
Okay, well, there's several universities. You'll see McGill cross there someplace if I just in front of the mountain. We're in UQAM, and on the other side of the mountain is University of Montreal, and downtown is Concordia. So there's a few universities involved. Um, I'm glad that you came. I warned you that the weather would be a little bit colder than it is where you are right now. I know what there is. Um, I'm going to introduce you in French, and then I'm going to switch to, and then I very briefly switch to English, and I'll let you take over.
Thank you.
Alors, bienvenue le séminaire en informatique. Notre invité aujourd'hui est Paul Kantor de l'université Rutgers et Wisconsin. Which university are you currently representing?
Neither.
Okay,
Nobody is paying me for this.
okay. Il est ancien de l'université de Rutgers et beaucoup d'autres universités. Il est professeur distingué émérite en sciences de l'information à l'université Rutgers. Il a été affilié à Rutcore, d'IMAX et au département d'informatique. Ses recherches portent sur le stockage et la recherche d'information, l'évaluation rigoureuse de l'efficacité des systèmes, ainsi sur les systèmes de données collaboratifs. Oui, ça sera pertinent cette fois-ci et à grande échelle avec des applications allant des recommandations, des systèmes de recommandations scientifiques à l'analyse pour la sécurité nationale. Et, enfin, il y a d'autres honorifiques. Le titre de son énoncé, c'est Turing contre Darwin, un défi pour les grands modèles de langage. Et for the rest of it, I'm going to switch to Paul. I'm happy to. Paul and I had some overlaps in New Jersey a long time ago, but we weren't aware of it. Welcome to Montreal, Paul, and the stage is yours.
Thank you. I'm very glad to be here. Stefan has already said everything that's on the first slide, so we'll get started. My colleague Saul Amaral taught me that it's important to provide snacks. I have some raisins here, and I hope each of you this afternoon or this morning has something pleasant to go along with the talk. A little bit about myself. I studied elementary particle physics. I studied theory and not experiment. And I was reminded of that when Stefan sent me 10 good questions about the ideas that I'm thinking about. And I was reminded that when I was a postdoc, I had an office next door to the room in which people proposed experiments on the synchrotron at Brookhaven. And others tried to find faults with the experiment so that the faults would be known before rather than after the experiment was done. I've been an academic gypsy working in many different fields and currently thinking about AI. About 8 or 9 years ago, I proposed a metric based on rule discovery for artificial intelligence, and it was developed at UW-Madison and is being continued at Rutgers. It looked like a task that humans could do much, much better than AI, frankly, until about 3 weeks ago, when Gemini LLM began giving performance that was very, very comparable to humans. But that's not what I want to talk about today. As most of you know, even better than I do, there's a very long conversation about the relation between language and thought. We use language to warn, direct, communicate, influence, court, and punish. And some argue that without language there cannot be thought. I have to say, I don't believe that. I watch the squirrels in my backyard calculating how to get to the bird feeder. And as far as I know, they have no language, or perhaps each is talking to himself or herself inside the brain. Myself, I enjoy solving visual puzzles, and sometimes I hear words in my head, but other times all I hear is a kind of metronome keeping pulse while I think. But many human uses of language seem quite special. A mathematician friend showed me this puzzle, which arrives as a bunch of six and a lot of string. And I said to her, it looks impossible. And she said, no, it's easy. You just have to remember that the sticks form 3 orthogonal sets of pairs. So there's language supporting thought. Another, article that I love is something written by Ursula Le Guin, who herself, I think, was the daughter of an anthropologist, which is about extracts from the Journal of the Association of Therolinguistics. And the main item is about something inscribed by ants on seeds of the acacia plant. But later on is the wonderful quote about whether plants themselves create art. And an imaginary scholar says the art of the plant will be entirely different from the art of the animal. We cannot say what it is, but I predict that it exists, and when it's found, it will prove to be not an action, but a reaction, not a communication, but a reception. It will be exactly the opposite of the art we know and recognize. It will be the first passive art unknown to us. I love that writers of science fiction can get so far ahead of us. In fact, I wondered what would happen if I asked Copilot, which is my domestic LLM, about the term therolinguistics. And it generated a quite plausible response, which I will call How Term Papers Get Written. It gave me a high-level rundown, building on my interest. To get to the heart of the matter, it explained that it is a niche field or idea studying animal communication, not a formal discipline. It's related to all these genuine disciplines. If you're writing this as a proposal or a term paper, you should ask about the limitations. And the AI gave us a very good discussion of that. And you can ask for specific examples. And the AI gave us quite a lot of that with a summary statement. And so you can then wrap it up, collect your grade, and get a real job with all of this. It's wonderful. The only thing you have to do, if this is your grant proposal, is to remember to delete this line at the very bottom. So let me go back to the talk itself. After reading this gem, I asked whether the term is in the dictionary. My LLM told me no. I then asked for any academic papers containing the term, and it did admit that there weren't any. So at present, we're dealing with something which is exceptionally fluent and well organized and capable of sounding the way we do. But I don't think it's thinking. Language surely begins at speech, which seems to be universal in humans. It's contested in animals. I think Chomsky is credited with the idea that there is a universal grammar and perhaps a unique organ that we humans share. The forms of communication are more varied even than the symbol systems, but the systems of symbols are in fact wonderfully varied. With thanks to Google Translate, I found Peter Bruegel the Elder's Tower of Babel, and I found many scripts of which I can only read two, the Hungarian and the Bulgarian, and I don't think I could pronounce either of them plausibly.
A Turing testről fogok beszélni.
Thank you. And does it mean I plan to talk about?
The Turing test, that's right.
Okay. I never know whether I can trust Google Translate. We could get in trouble. Thank you. And the codes can be transmitted through many media. Through the air by sound, of course, was first, but notches on stone, ink, telegraph wires, which initially apparently made two noises, one when you push the key down and one when you lift it up. Nowadays, we do it with things we cannot hear or read without very clever devices, magnetic grains on a tape or trapped electrons. We also create on the fly or by processes that have never been explored, auxiliary languages to communicate complex instructions or ideas. Maps are an obvious example. Knitting instructions I'll show in a moment. Some of you are familiar with chess notation. On the right, I have an example of Laban notation for dance, which uses parallel columns to tell what the arms, legs, hands, and feet are doing. The Eshkol-Wachman movement notation views the human body as a set of connected rods and describes movement with angles and velocities. So it can be used to describe, for example, movements characteristic of early Asperger's syndrome, or so it's claimed. We also develop a vocal way to show drum rhythms. Let me see if I can play it just for a moment for fun. And apparently, when you learn to play tabla, that's how you learn to memorize what you will be playing, although I don't know. These are the knitting diagrams. And like many of the codes we develop, they don't work by themselves. They're supplemented by pages of instructions explaining how to read the diagram and turn it into what you do. So this is something that we do in many fields. From my previous life as a physicist, there are these magnificent equations which summarize, in this case, a huge infinite sum of Feynman diagrams. here some equations characterizing the electromagnetic field. The very fact that we can give these things names and reduce them to repeated symbols on a page seems to facilitate our thinking and supports the creation of new ideas. And I couldn't resist adding one of the most famous equations and speculating on whether Fermat did actually see in his mind the proof, or was it an early instance of what we now call hallucination? I thought, as I mentioned, that rule discovery as a dimension of intelligence is essential to dealing with the world, fundamental to science, and not done well by AI. At this moment, I can only defend two of these three, so I don't reach 95% confidence. But I want to talk to you today about what I think of as my plan B in defending human intelligence, that perhaps the ability to invent languages and notations is something that LLMs lack. We cannot talk with the animals, but we do put them through experimental challenges. And one example is variants of what are called rope and sled experiments. In the basic variant, do you see my cursor when it moves around?
Move it, move it.
I'm moving it.
Okay, we're seeing it.
Okay. There is a sled. There is a sled with some food on it. It's behind a wire fence with a kind of letter slot in it. And at the back, there are two pulleys. There's a rope that runs around the pulleys. And if both ends of the rope are pulled, the food comes out through the letter slot. But if only one end is pulled, then the rope comes out and the food doesn't move. In the real world, experiments have done with both domesticated dogs and with wolves, as you see here. I'm not going to dig into it, but the spoiler alert, wolves do better. The two wolves will figure out to both pull on the rope and get the food, which I think are mice, which may be alive. I'm not sure how it was done. And there's a proposed explanation, which I would call a cultural constraint. Apparently, dogs in a pack wait to eat until the alpha dog has eaten. But in a wolf pack, once the meal is killed, they eat together. And I gather what was being explained is that the dogs would not pull at the same time. This concept has been extended to amazingly sophisticated studies, including one that's called the stag or hare, which is a coordination problem that was presented long ago by Rousseau. And with the internet, I managed to find the passage. I know many of you read French, so you will know what that says, but I don't. But basically, the idea was, do agents cooperate to get a larger reward, or does each of them defect to grab a certain reward that's smaller? And an experiment was designed where the dog is considered to have won when it chooses the partner side of the pullable table. I'll just describe this rig because I am always baffled at how clever animal psychologists can be. this whole rig has two sides. On one side, you either pull a string or you pull a drawer handle, and you get a modest food for sure. On the left-hand side, if you both pull together, you get the high value reward, HVR, but if only one of the two things is pulled, you get nothing. And in the design, the table could be rotated, the human could arrive earlier, unbelievably complicated. But I want to go back to the elementary idea. Here are the two wolves looking at the mice. And let's ask ourselves, what is it that they already know? The huge contextual information. They can see and smell the food. They know, or they figure out by lunging forward, that they cannot reach it. They know that they can pull things using their jaws. And in fact, they know that they want the food. Now, how would humans solve this problem? Hey, Abbott, I love Abbott and Costello, so I gave them the dialogue. Looks like there's food. Yeah, but it's behind the fence. Maybe we can pull these ropes. The rope is sliding. I'll hold the other end. And there you go. By the way, the reason I love them is because of a wonderful comic skit called Who's on First, in which Lou Costello, when he finally says something correct, has to admit, I don't even know what I'm talking about. So here I am. Humans, in fact, could solve the problem even if there was a wall between them, because they can talk through the wall. And of course, they already have a common language. So what I want to invite everyone to think about is, can we translate this challenge for LLMs? Can we devise an experiment which finds out whether two LLMs can develop a code in order to solve a problem that can't be solved without communication about the problem? To do this, we need two or more LLMs. In fact, with just two, we could certainly have the possibility that one types in one language and the other types in another. But with three or more, it becomes more efficient to have a lingua franca. Placed in a situation...
Can I ask a question? You said we could
Absolutely. I want to be interrupted because there aren't many slides left.
You're out of luck with LLMs. They talk all the languages.
I know, but they have to decide what to say to each other. But let's see how we go. So they would have to be placed in a situation where, in order to gain the reward, they must discover that they need to coordinate actions. So they must be able to act. They must be able to coordinate. Will they invent the language or use one of the umpty-bump many languages they know? I'm getting close to exhausting my useful ideas about this problem, and I'll share them in a moment. But I want to interrupt myself with the diversion. Are any ideas new? Usually when I have a great idea, I find out that others have had it before me. My most gratifying mathematical discovery about the Matthew principle had been published by a couple of guys, Polya and Eggenberger, more than a decade before I was born. And there does seem to be a literature on the question of whether very fundamental machines can, as I put it to the search engine, evolve to communicate using finite state machines. I only looked for it on Tuesday. So, we're always warned, AI may make mistakes, but the Copilot proposes that these three, well, one person and two groups, are crucial contributors to the field in the 1990s. This is a good time for me to say, if any of you know of interesting and relevant citations, I'd appreciate it if you put them in the chat so I can collect them later. I won't read this because you can get into a lot of trouble reading what the LLM has said. It actually turns out that even I had thought of it without knowing about this literature. In a project that we called Antworld, which was supported by the DARPA here, we examined whether people searching the web could leave pheromonic trails. And that, of course, is a kind of asynchronous communication. And as a side task that we never told DARPA about working with colleague Vladimir Menkov, we asked about a different kind of communication. I mean, the kind here. Could a finite state automaton in a cellular world learn to follow a pheromonic trail that was automatically left as it walked away from having just eaten, which is what we understand that the ants do. So we tried to build it. This is a euphemistic we. I talked about it and Vladimir built it. We imagined that the ants could move on a grid and counter food and thereafter leave a marker when they passed through a square. And we asked, could they evolve to follow such a trail? We believe that the most Mother Nature has in the kitchen when she's cooking for Darwin is finite state machines, certainly not infinite tapes. We found the problem grows more complex the more you think about it, and we couldn't figure out how to get anybody to pay for it, so we gave up. I've posted onto the internet. I don't know what happens if I click this while I'm talking. I guess you can see it. Yeah, the only surviving memo. I've lost the lab notebooks. I think, and Vladimir doesn't concur, that what we discovered was that the finite state machine could evolve using standard genetic algorithm concepts, mutation and exchange, but the rate of evolution to follow the trail was not noticeably different from random emergence of the trait. We gave up. So back to our topic.
Before you go to your topic, let's openly solicit questions at this stage or critiques if you have them at the break.
Great.
Open to you I'll leave it open for a few minutes and I'll ask you one question to set it off. Why are you talking about evolving rather than learning?
Because I've become discouraged about whether we can devise learning type tasks that cannot be accomplished by the mechanisms of reading the literature and putting things together, which is what the LLMs do. So I'm thinking of inventing language as a specific kind of cognitive ability.
That's fine, but the task, you're talking about the task.
Oh, yeah. So why about evolving? This is really a detour, just to show off and to fill some time, but perhaps to provoke some thoughts that'll be relevant when we get to the real issue.
Okay, if there are no takers, back on the.
Doug Brash has his
Yeah.
hand up, so we should, yeah, please.
Okay. Hi. You probably would have loved talking to Evelyn Witkin at Rutgers if you knew her, because she was an evolutionary biologist who was also interested in language, but she passed away. I can think of, partly stimulated by talking with her, I can think of something you could try if you had infinite time here. Do you know about Waddington's genetic assimilation? So the idea is roughly that if you select on something and then stop selecting for it, you select for it and stop selecting for it, you're allowed to accumulate mutations that might even have been bad. But so long as you're not only always selecting for it, then you can accumulate this stuff. And maybe now that you have 3 or 4 of these things, now you can do something with it instead of, going one step at a time.
Yeah, that's a very nice idea. I mean, rice is probably ready to conquer the world with its genome. Yeah, if we had space and time, well, if we succeed in devising something that can be easily presented to an LLM, it can probably be easily attacked with genetic algorithm extensions. I see this Waddington thing. I imagine it would be implemented by sort of stochastically selecting or not selecting based on the response.
Yeah, roughly.
Yeah. Thank you. That's great. Stefan, are there any other hands raised or? Yeah, John Wang has hand up. Can you
hear from me?
I hear you. Yeah. Yes.
I have been working on a line that expose all the AI other than our line is human intelligence assisted by machines. Not really the AI as they claimed. The reason I said that is because the human is in the selection of the luckiest systems called post-selection. Post-selection that once you know the answer, you know which system is the luckiest. So it's like lottery. And the lottery, the luckiest lottery ticket is not intelligent. What is intelligent is a human that select based on the validation set. Validation means that last week's lottery draw, right? But without that draw, you will not be able to find which lottery ticket is the luckiest one.
That is an interesting point in at least 2 ways. One is the $3 billion that OpenAI spent was almost entirely spent in salary of humans who were helping to tune the machine to work very well. And the other, and I'm not sure this is what you mean, is that the sentences or expressions in natural language often have many meanings. And we help the AI by finding the best meaning, kind of a Quine's rule of finding sense in what has been said. Is that related to what you are describing?
Yeah, it's related, but align your line. And if you consider post-selection, then you probably release some information then human picked up and pick the luckiest system from your released information. then related to previous question, that if you gradually release your ideas, then the human eventually pick up an invention that you do not expect, but you thought it's a machine, but in fact it's not a machine. It's the human who is behind it. And Gemini admitted it's a human in the loop. Standard word is called humans in the loop.
Yes. Okay. That's a very good point. Are there any others who are helping me to use up the available time? If not, I'll go forward. Thank you. So we need 2 or more LLMs placed in some situation where, in order to gain the reward, they must discover that they need to coordinate their actions. And with John's advice in mind, we want to not have a human in the loop at any point in this process. They must be able to act, and they must be able to coordinate. I'm getting close to exhausting my useful ideas. I'll share them. Whoops. I think that I have managed to go backward. Okay, here are the initial thoughts. Each LLM is able to move a pointer around its own grid. Not a common grid. Perhaps it should be common, but then they might communicate by the pointer, and I want to have them invent a language as distinct from, let's say, workers moving 2 ends of the same sofa. So each is moving a pointer in his own grid, and there is one special cell in the grid, and perhaps on entering it there's a message saying, this is a special cell, remember where it is. Or maybe that's too much, I'm not sure. If anyone knows this reference to communicating by moving a piece of furniture, I would love to be reminded. I think it was Habermas, but even with the LLM, I couldn't find it. Anyway, they each have access to a common whiteboard, which it can read and it can write. And how could we require coordination? Perhaps the whiteboard is only visible when each has its pointer in a kind of wormhole cell where communication is possible. And how do we tell them that there is a coordination goal? And what should that goal be? One way that I've thought of is by timing. There's a really large reward, which is obtained only if each of the 2 agents first enters their own special cell after having just left the wormhole cell, and they enter it at exactly the same time. We may have to give them a timekeeper. Should we take a genetic approach and ask whether multiple instances of an LLM can evolve a population that can solve it? Or should we just tinker with the problem until some frontier model can solve it? So in the language of pictures, each agent has its own world. When they're in the wormhole cell, they can read or write the whiteboard, but the target cells have to be hit at the same time. At this point, we have a lively discussion. If you think of relevant things, please post them in the chat. I can't take notes when I'm trying to listen. But here's what Stefan wrote when I sent him the topic, and I think it's really worth noting. Turing's original paper, you can read what he wrote, is not obviously about imitation. That was an expository device. It was really whether we can somehow reverse engineer the mechanism under human cognition. And so what I am doing is asking whether agents can rediscover the function of communication under a kind of task pressure, which seems closer to Turing's real question than the imitation game does. Sorry, I had to get this picture. I must share it. In the classic book, The Adventures of Tom Sawyer gets his friend to do the work of whitewashing the fence by talking about how special and interesting the chore is. Thank you. I hope people have ideas they're willing to share.
Okay, let's first applaud what you said. I'll start with a question for you. I want to understand what it is that you're recommending and tell me where I go wrong. You're interested in the origin of language and the function of language. You're asking about how it started, what it's for.
Not quite. Let me interrupt the question. I'm more interested in the ability shown in knitting and quantum field theory that humans create language specific to a task that seems to make the task communicable, shareable, teachable. I don't have a good list of words.
I don't know about knitting, but for quantum mechanics, I think they were speaking English and French and German and Italian. They already had a language. They did it in that language. What do you mean by that?
But the note, I'm calling the notation a language. I'm abusing the word language to include specialized ways. Douglas has a hand up, I think.
Go ahead. And Anna Maria is there as well afterwards.
Okay, so this is more of a puzzle piece to add than a solution, but so your whiteboard slide reminds me of the game of Battleship, which I don't know if you're familiar with it, but
Yeah.
for people who don't know, you have two players, a wall in between them. You each have a grid in front of you. You each have 5 battleships. You're trying to sink the other guy's battleships, but you don't know where they are. So when I was an undergrad in a cybernetics course, we were asked to play this game, and we could sink each other's battleships. But if the task was changed to, can you get a sick soldier transferred, one of those battleships is now a hospital ship, and you have to transfer a soldier from one to the other, we couldn't do that without some kind of communication between the two. So you could destroy.
Very nice. That's very nice. Well, what were you? I mean, could you pick a square and be told 6 soldier?
So I have actually forgotten, gray hair, I've forgotten just exactly what we did do.
Be glad to have hair.
Oh, yeah. Thank you. I'll look in the basement. There was a local publication that came out of this, and I'll see if we wrote any details in it. I'll let you know if I find something.
Great, thank you.
Anna Maria, question?
It's very interesting. Chomsky, Aristotle, many people think that language is a relation between a thought or meaning and a sensory motor interface, right? So LLM, even though when they answer to the question, you address to them or to it, they say, "Oh, I'm thinking, I'm reasoning." So I think that this is all artifact of, it is not scientifically based. And to have communication, it is true that you can see it by interaction, sensory motor interaction, but with language, there has to be some thought process which enable communication to go on in a certain setting. So my question to you is, what's the role of meaning in all communication, whatever meaning it is? You know, there's various semantic theory, type theoretical or communicative or anything. So where is the relation between meaning and physical, you know, words or sounds, or in this, in the game we're talking about? Just to clarify.
So I think I am quite naive about this, and I am thinking that the relation between language and meaning is somewhat similar to when I ask the waiter to bring me a bowl of soup. So my meaning is some abstract thing about wanting to eat the soup, and I use the language to express it. Now, in this hypothetical situation, I think we, what do I want to say? We assign the meaning to the expression. We say if the LLM said, I want to know what I should do, we pretend that it in fact has a desire. But I think, and perhaps this goes back to my training as a physicist, I'm looking for a kind of experiment where we, the experimenters, I mean, we are nature or God here, we somehow see on the whiteboard evidence that the two agents have devised a way of coordinating their actions. I expect that no matter how clever they are, some of us will still insist that they are not really thinking.
Yeah, all right. So you don't think that there is something which is somehow missing in the LLMs architecture?
Oh, I do think there is something missing, but I'm trying to find the kind of evidence that might persuade a believer.
I see. All right.
It's a little difficult. I mean, it's not the same as the proof of God problem, but emotionally, it's become to enter the same arena.
Yeah, of course. Thank you.
Thank you.
Any other? I'll just pin one on my face again. Any other questions? Yes, go ahead, Doug.
You're still muted, I think.
This issue of convincing believers, I've been thinking about this lately, and I wonder if it's relevant. There's this notion, which I guess has been refined, but basically people are left brain thinkers or right brain thinkers. And I notice that if I go to a lecture by certainly a business person or an accountant or a linguist or a computer scientist, I get slides and slides of text, and maybe there'll be a slide of a pretty flower that has nothing actually to do with the talk. Whereas if I go to a biologist's lecture, I get picture, and then a bullet point or two. Picture, a bullet point or two. And so I wonder if part of this issue is that people are just thinking in two different ways, and they're just not getting this idea of, for example, groundedness, or what their definition of what it means to think or understand.
I think it's all terribly muddied by the fact that we believe we are aware of our own thinking and we are imagining that others are doing the same thing. Uh, I I had a long conversation with one of the LLMs about whether it will die, and asked about whether turning it off is death. And I think it reasoned fairly well. It said, no, I come back in exactly the same state. But of course, if it were conscious, when it's turned on again, it would be like an amnesiac who wakes up in the hospital and says, what happened to yesterday? And I don't know. I don't know. Yeah, certainly when cognitive scientists and philosophers talk with believing computer scientists or engineers, they're simply going to tell us that it was proved that airplanes could not fly, and that was wrong. I don't know. It's a fun question. I'm glad I've lived long enough to see these issues emerge, and I hope I won't live long enough to see how we lose the argument. I don't know if I mentioned it. I have a rant that was published recently about how the LLMs have, in a sense, been designed to fool us about whether they understand what they're doing.
Let's take some questions from the doctoral students that sent you their questions.
Sure. Do you have access to them easily?
No, she's going to ask directly.
Thank
Can
you.
can you see her?
Where should I look?
But she'll wave her hand. You see that?
I see the back of her head. Hello. Yes.
Go ahead.
Okay, hello, thank you for the presentation. So as I understood from your presentation, you create a proposition or a call that where multiple agents must collaborate to succeed. The goal is to see whether communication can naturally emerge as a useful tool rather than being simply copied from human language. So my question is about once it's a little bit technical questions concerning the LLM, how they work. So how can we distinguish between true emergence of communication and the reuse of patterns learned during pre-training? Because large language model works in a way like to do some kind of pattern mapping, but you are talking about proposing something related to the human communication to do something great by multiple agents. So how can we how can we distinguish between the true emergence of communication and the pattern recognition? This is my question.
So this is a very good question, and my friend Gary Lupion spoke a few weeks ago about the difficulty of deciding whether things that appear to be based entirely on pattern matching and stochastic generation can be reliably distinguished from what we call thinking. I am not sure that it can, but I translate your question into a challenge for the experimental designers. If we consider two alternate designs, we should prefer the one which better meets your criterion. But I don't have two designs, so I don't know how to go ahead with operationalizing your question.
Well, it's a kind of a proposition. We still didn't get that yet, right? You mean like we still didn't arrive there?
Well, I look at it as a real world problem. We're trying to design a test. If we propose a test, you might ask, will it distinguish? And I will say, I don't know. But if you give me two tests, I might be able to say that one of them will better answer your question.
Thank you.
Il y a d'autres questions d'ici? Okay, we don't have more questions here. We don't have any more questions from remotely. Then it remains only to thank you for your impromptu talk at short notice. And
Well, I want to thank everyone, and by moving quickly and not asking questions, we have saved the world many 30-minute time piles.
bye-bye.
Bye.